This is Eric Michael Lloyd. I have a master's in psychology, neuropsychology concentration. Today I wanted to read an article from the Epoch Times. This was from the issue June 11th through June 17th of 2020. Microglia. The brain's immune cells protect against diseases, usually. When the cells switch to their aggressive form, they can kill neutrons and cause further damage to our brains. So just from that part alone, it seems that they can actually affect the elements, the atoms, and affect the nucleus, neutrons, the neutral charge in our brains when they switch to the aggressive form. This article is by Nephthira Kodasaki, and it's on microglia. States here, microglia do, in one of the captions, it states that microglia do much more than support the neurons. They nourish, protect, and sometimes even destroy them. We know the body's immune system is important for keeping everything in check and protecting us. But a lot of us don't realize that the brain has an immune system. Microglia, which are the brain's immune system cells, are involved in everything from brain development to protecting against diseases such as meningitis and Alzheimer's. But for all the good these cells do for us, under the wrong conditions, they can also cause us harm. Microglia belong to a group of non-neuronal cells called glia, which originally were thought to play a supportive role for the brain's neurons. Now, research shows that microglia actually do much more than only support the neurons. They nourish, protect, and sometimes even destroy them. These cells are unique because they come from the same place as other immune system cells, but have a different origin from other brain cells, which develop from neural stem cells. So the microglia are unique because they come from the same place as other immune system cells, but they have a different origin from other brain cells, which develop from the neural stem cells. Microglia come from the yolk sac, an extra embryonic membrane, and travel to the brain early in its development. Once established, microglia perform numerous functions. They help neurons connect, clean the brain of waste and dead or injured cells, constantly check everything is in order, and defend the brain from external threats such as microbes and internal threats, including misfolded proteins, when a protein takes on the wrong form, which can cause disease. Their ability to change physical form and behavior in response to their environment allows them to perform these many roles. Microglia functions are especially crucial during brain development, when they help young neurons grow and ensure the right connections are made between neurons. Through a procedure called pruning, microglia eat connections between neurons, maintaining strong ones while eliminating weaker ones or unnecessary ones. This continues somewhat during adulthood. For example, microglia remove unimportant memories by eating or altering synapses involved in their maintenance. Faulty pruning during brain development has been linked with disorders such as schizophrenia and autism. But uncontrollable pruning by microglia in adulthood has been implicated in developing diseases such as Alzheimer's. Microglia have specific receptors on their surface that recognize distress signals from other cells. These signals attract microglia to the site of the problem. When the brain's balance is disturbed, usually as a result of inflammation, living neurons can become stressed and produce these signals. This may cause them to be eaten alive by microglia. As neurons are killed, the connections they have with other neurons are also eliminated, which can cause severe issues in brain connectivity and functions. Inflammation in the brain can be caused by stress, pathogens, and autoimmune conditions, and is also connected to inflammation in other parts of the body. Brain inflammation is common in neurodegenerative diseases, as well as mental health disorders, including depression. Inflammation causes microglia to change roles and turn into their aggressive form to defend the brain. Usually, when stress signals stop and anti-inflammatory signals are received, microglia go back to first repairing, then protecting the brain. I'll read that part again. Inflammation causes microglia to change roles and turn into their aggressive form and to defend the brain. Usually, when stress signals stop, anti-inflammatory signals are received, microglia go back to first repairing, then protecting the brain. But there are cases, such as with chronic stress, aging, and neurodegenerative disorders, where microglia can become more aggressive and less easy to regulate, making them more dangerous for the brain. In these cases, microglia can increase in numbers, unnecessarily kill nearby cells, and may contribute to making the brain even more inflamed by secreting inflammatory molecules. They also don't go back to their protective role easily. Look after your brain. But there are many things we can do to keep our microglia happy and our brains healthy. Maintain a healthy diet. Compounds found in fruits, vegetables, and healthy fats can keep your microglia young and shift them towards an anti-inflammatory form. Fruits, vegetables, and healthy fats. Keep your gut bacteria happy. The brain and the gut are connected by the vagus nerve. So microbes living in our gut, the brain and gut are connected by the vagus nerve. So microbes living in our gut have a large effect on the brain. These microorganisms are involved in the development, maintenance, and overall health of microglia. Avoid alcohol and smoking. Alcohol causes brain damage. A recent study found that one of the ways it does so is by activating the microglia's inflammatory response. Research shows this activation is also induced by a specific compound found in cigarette smoke. Sleep. Microglia never sleep, but they clean and repair the brain and improve memory while you do. Lack of sleep, however, has also been shown to make microglia take on their inflammatory form. Take care of your mental health. Microglia can sense stress, and they respond to it by turning into their inflammatory form. This form is present in numerous neuropsychiatric disorders and also, in some cases, mental health issues such as depression that precede neurodegenerative disorders. It has also been shown that anti-inflammatory treatment can help with managing the symptoms of psychiatric disorders and that some medications used for the treatment of mental health issues have an anti-inflammatory element. Antidepressants have also been shown to directly regulate microglia responses. Exercise. A recent review found exercise directly affects microglia and shifts them toward having a protective form. Exercising the brain has also been shown to train microglia to resist Alzheimer's disease. Although we know some things about microglia, we don't know everything. We know some of the things about how they form, that they're involved in many diseases, and that they might essentially control the brain. But we also know we can't control them. Future research might focus on how we can stop microglia from causing diseases and how to stop these cells from turning against the brain. Eleftheria Kotosaki is an academic associate of the Cardiff Metropolitan University in the United Kingdom. This article was first published on The Conversation. Thank you for your time.